So in this first question of homework 2, we're presented with a table. Before we tackle any of the questions, let's briefly look at this table. So we're presented with two different groups, the Vioxx group and the naproxen group. We're given the number in each group, the person years of exposure, and the number of heart attacks in each group. Okay? So the first question is asking us to calculate the absolute difference in the incidence rates of heart attacks for Vioxx versus naproxen. And it wants us to put that in units of 1,000 person years rounded to 1 decimal place. Okay, cool. So what we're going to do is we're going to treat each group separately. Okay, so first we're going to do Vioxx. So to calculate the incidence rates, or the number of heart attacks per 1,000 person years, we're going to do 20 over 2698 times 1,000. Okay, and so that's going to be 7.4 basically heart attacks per 1,000 person years. Okay, and then so we're going to do the same thing for the naproxen group. We're going to do 4 over 2699 times 1,000. Okay, I'm going to write that lower here. So that's going to give us 1.5 heart attacks per 1,000 person years. Okay, and to calculate the absolute difference, all we need to do is subtract 7.4 minus 1.5 to give us 5.9. Okay, so this is 5.9 excess heart attacks in which group? It's in the Vioxx group, right? Okay, so that is the answer to the first part of this question. Moving on to the second part of this question. So the second part of this question asks us about the absolute difference in the risk of heart attacks for Vioxx versus naproxen, represented as a percentage. So to calculate this, what I'm going to do, and this actually might be more straightforward than the first part of this question, is just take the number of heart attacks and divide that by the number of people in each group. Okay, so I'm going to do 20 over 4,047 minus 4 over 4,029 to get about 0.0039, which gives us 0.39%. Okay, so this is the absolute difference in the risk of heart attacks for each group, and that's because this is the probability of a heart attack in the Vioxx group essentially, and this is the probability of a heart attack in the naproxen group. The third part of this question is asking us about a rate ratio. Now remember, whenever you see rate ratio, you think time. Okay, there's a component of time in this. So in order to calculate the rate ratio comparing Vioxx with naproxen, okay, what I'm going to do is take these numbers. Okay, so we're going to do 20 over 2,698 divided by 4 over 2,699. Okay, and that's what that's going to give us is a standardization across the number of person years of exposure. We're standardizing against the exposure, the number of heart attacks in each group. You can think about it like that. And so the rate ratio here works out to be 5. The last part of this question is asking us about the number needed to harm. And if you remember, the number needed to harm can simply be calculated as the reciprocal of the absolute difference in the incidence rates. Okay, and so we already have that from part A. If you remember, that was 5.9 events per 1,000 person years. So the reciprocal of this is simply going to be 1,000 divided by 5.9, and that's going to give us a value of 169.49. So this is the number of patients needed to be treated to receive harm. So moving on to the next question, we're again presented with this figure. Let's take a look at this. So there are 3 categories here: a single pill per day regimen, a 2 pill per day regimen, and a 3 or more pill per day regimen. And these are adjusted risks of hospitalization by each cohort. Okay. So moving on to the first part of the question, it's asking us what % of single pill users were hospitalized during follow-up. Well, that's easy. That's given right here at 7.7. Okay, the second part of this question is saying what % of 3 or more pill users were hospitalized during follow-up. Well, we're just going to look at the bar for 3 or more pill users, and look, oh, it says right there 9.9%. So then the third part is asking us to calculate the risk ratio comparing the risk of hospitalization in single pill users versus 3 or more pill users. Okay, so what that's going to be is simply the probability of hospitalization in this group divided by the probability of hospitalization in this group, or in other words 7.7 divided by 9.9, which is 0.78. Okay, so the risk ratio is 0.78. So this next part is asking us to calculate the odds ratio now of comparing the odds of hospitalization in the single pill per day regimen versus the 3 or more pill per day regimen. And so if you remember, the odds in odds is defined as the probability over 1 minus the probability. So if you take 7.7 as the probability of hospitalization for the single pill per day regimen group, you can represent the odds as 7.7% over 1 minus 7.7%. Okay, and we're going to do that with the 3 or more pill per day regimen group. So that's 9.9% over 1 minus 9.9%. Okay, and this is going to give us the odds ratio. So if we simplify this, we're going to get 0.76. The odds ratio here is 0.76. So let's take a look at this third table presented to us here on homework 2. So there are 2 groups here. There's a group that received a weight reduction of 5 kilograms or more, and then there's a group of patients that experienced a weight reduction of 10 kilograms or more. Okay, and the authors are sort of representing this in a strange way, but basically notice that in this placebo group, in both categories, there's 45 patients. Okay, so 3 patients here experienced a weight loss of greater than or equal to 10 kilograms, and those 3 also experienced a weight loss of greater than or equal to 5 kilograms. Okay, so these aren't mutually exclusive, they're just representing the data in different ways because they performed 2 different analyses here and here. And so there's a placebo group, and then there's a group of patients that were treated with 1 drug at 3 different doses, at 0.25 milligrams, 0.5 milligrams, and at 1 milligram. Okay, and odds ratios are presented for each group. Okay, so this is of course the odds ratio, this is the 95% confidence intervals, and this is the p-value associated with this effect estimate. So now that we have all of that understood, let's take a look at the questions. The first question asks us why the authors reported an odds ratio rather than a risk ratio or a rate ratio for these data. Well, it certainly does seem strange given that the study was a randomized trial, which does contain information to calculate rates and risks from their data. So the answer is not C. Odds ratios are not the preferred measure of relative risk. Okay, the preferred measure is of course the risk ratio. The data does not come from a case control study because the stem of the question tells us that it's a randomized trial. So that leaves us with B. They analyzed the data with a logistic regression. And this is the correct answer. The reason they used a logistic regression was to control for confounders. Okay, so you can put variables as into a logistic regression as independent variables in order to adjust for any confounding effects that you might see. And the output of a logistic regression is an odds ratio. And so the authors just reported that output in this table. Okay, the next part of the question is asking us to calculate the unadjusted risk ratio for the comparison of the 5 kilogram weight loss group. Okay, and we're specifically looking at the 1 milligram dosage of this drug. So the numbers of interest to us are this number and this number. So this is the 1 milligram dose, this is the placebo dose, that's what we want to compare. And we want to compare it in the 5 kilogram weight loss group. And so to calculate the risk ratio, that's simply just going to be 91%, or the probability of losing greater than or equal to 5 kilograms if you're taking this drug, divided by 29%. Okay, and that calculation works out to be about 3.1. So the risk ratio is approximately 3.1. The next part of this question is asking us to calculate the adjusted risk ratio based on this adjusted odds ratio that's given here. Okay, and we are provided with the conversion formula in the problem set. So I will write that out here. So the conversion formula is the risk ratio equals the odds ratio divided by 1 minus the probability in the reference group plus the probability in the reference group times the odds ratio. Okay, so I'm just going to substitute what we know here. We know that the odds ratio, the adjusted odds ratio rather, is 31.5. So let me write that in, 31.5, 31.5. Okay, and then we have this probability in the reference group variable, and that's actually just going to be 29%. Okay, so it's the same thing. We're still looking at this category of data. The reference group is the placebo group, and the probability is represented by this percentage. So we're going to write that in. So this is going to be 29%, 29%, or 0.29, right? And then when we do out this calculation, we see that the adjusted risk ratio is 3.2. And of course, this is the adjusted risk ratio because we're using the adjusted OR to calculate this and to make this conversion. The last question in this homework set is asking us what the best way would be to represent this very large odds ratio here, 57.7. It's very rare to see odds ratios above like 2 or 3 or something. So a 57.7 odds ratio here is huge. So A is incorrect, right? Because it doesn't, 57.7 is an odds. So it doesn't represent that person's chance or probability of losing at least 10 kilograms on this drug. The best answer here is C. Okay, the odds ratio is always misleading. It always exaggerates the effect away from the null when compared to the risk ratio. So generally speaking, it's best practice to only report the odds ratio if you also give the readers, or if you also report the unadjusted or adjusted risk ratio. It's really hard to understand the odds ratio or an odds intuitively, and so while B is technically correct, it is likely to mislead most readers, and the best answer here is C.